This is Algebra 2, Unit 6, Lesson 8b, completing the square to find the vertex. So how do we take the quadratic y equals ax squared plus bx plus c form and change it to its shifted or vertex form, which is y equals a times x minus h squared plus k? Remember, we can use that to find the vertex. Well, actually we use completing the square that we learned back in Algebra 1, and we did some review in geometry. So let's review how to do this. So suppose we want to write the quadratic y equals x squared minus 4x minus 1 in vertex form. To complete the square, so I want to take this, complete the square. First thing I want to do is move the c term, which is the constant term, to the other side of the equation. So I'm going to add 1 here. So that gives me y plus 1 equals x squared minus 4x. Now, to complete the square, we take half of the b term and square it. So remember, the b term is the term with the x on it. So this is negative 4, so we take half of that and square it. Half of negative 4 is negative 2. So I'm going to add it here. Negative 2 quantity squared. And then I'm going to add it over here. So we know negative 2 squared is 4, so this actually simplifies to be x squared minus 4x plus 4. And this is y plus 1 plus 4, which is y plus 5. Now, the reason that we took half the b term and square it, because we want this to be a perfect square. If we factor x squared minus 4x plus 4, it will factor as x minus 2 times x minus 2. So you can see that this is a perfect square. X minus 2 times x minus 2 can be written as x minus 2 quantity squared equals y plus 5. So we factor the resulting trinomial. We write the factors as a perfect square. That's this right here. And then we move the c term back to the other side. So minus 5, and y equals x minus 2 quantity squared minus 5. So now we have this in vertex form. So what is your vertex? Well, remember, in our form here, the vertex comes from this term right here and this term right here. So your vertex is actually at 2, negative 5. So the vertex is at 2, negative 5. Now, if I want to verify that I did that correctly in my calculator, I can do that. I'm going to do it on the color calculator so you can see what it looks like. I want to make sure, first of all, that I did this correctly. So I'm going to put the original equation in, x squared minus 4x minus 1. And then I'm going to put in my vertex form to make sure that I did it correctly. So parenthesis x minus 2 quantity squared, and then minus 5. Now when I graph this, the blue one is the original, and the red one is the vertex form. It's exactly the same. It lined up perfectly. And if I look at my calculator here, I can see that my vertex is at 2, 1, 2, 3, 4, 5. And I can verify that on my table as well. So that's the correct formula. So that's completing the square. So let's do a little practice on that. All right, so our first step, if we want to complete the square, is move the c term. So we're going to add 2 to the other side. So y plus 2 is equal to x squared plus 6x. Now I want to take half of the b term and square it. Half of the b term and square it is going to be 6 divided by 2 is 3, and square it is going to be 9. So I'm going to write it here first so I know where those values came from, because I want to point something out. Oops, 3 squared. I want to put that there. Okay, so this works out to, that should be equals y plus 2 plus 9 equals x squared plus 6x plus 9. All right, now when I factor x squared plus 6x plus 9, it should be x plus 3x plus 3. What I wanted to point out is, notice whatever you took half of right here is the factor that you use for your factored form for the perfect square. So this is y plus 11 equals x plus 3, which is y plus 11 equals x plus 3 quantity squared. And then subtract the 11. And that gives you y equals x plus 3 quantity squared minus 11. So where is your vertex? Your vertex, remember, it's the opposite sign that's here, is negative 3. And the same sign that's here, negative 11. There's your vertex. Okay, once you get good at this, you can do stuff in your head, but it's helpful to know what your values are when you do this. Let's try this one. Let's see if I can do it without writing it every step down. So subtract the 27, y minus 27 equals x squared minus 10x. All right, now if I take half of the b term, it's going to be negative 5, and the negative 5 squared is 25. So y minus 27 plus 25 equals x squared minus 10x plus 25, because I added negative 5 squared to both sides. All right, and remember, that's going to be my factor when I do this. So this is actually going to factor as x minus 5 times x minus 5, which is x minus 5 quantity squared. Now, be careful. Watch your signs when you combine over here. Negative 27 plus 25 is y minus 2. And when I move my 2 back over, I get y equals x minus 5 quantity squared plus 2. So my vertex is actually at same sign, or opposite sign here is 5, same sign here is 2. My vertex is at 5, 2. Okay, now this will work even if your b term is a little bit messy. It'll still work. So I'm going to do the same thing. I'm going to subtract 4, move the b or c term to the other side. All right, now to take half of the b term, b is 5. So if I take half of the b term, it's 5 over 2, or 2.5. So you can use the fraction form or the decimal form when you do this. Actually, the fraction form is pretty easy, so I'm going to do it that way. So this is going to be x squared plus 5x plus, well, 5 squared, or 5 over 2 quantity squared, 5 times 5 is 25, 2 times 2 is 4, is 25 over 4. Don't let that freak you out because you know what the factor is going to be. And this is going to be y minus 4 plus 25 over 4. Now, you can use your calculator on this. Negative 4 plus 25 over 4 is equal to 9/4. Or 2.25 if you really want to do it that way. And then we know that the factors of 25 over 4 are going to be 5 over 2. So it's x plus 5 over 2, x plus 5 over 2, which is x plus 5 over 2 quantity squared. And then move the 9/4 back, x plus 5 over 2 quantity squared minus 9/4. So your vertex, if you did it as a fraction, is 5 over 2, negative 9 over 4, or, yes, you can do it as decimals, 2.5, negative 2.25. So that should be your vertex. So that is completing the square when you have your x squared value. Now, completing the square can still be used to put a quadratic in vertex form even if a doesn't equal 1, although it's a little more complicated. So in order to complete the square, we want x squared to be positive, or to be 1. So how do we get rid of this? Well, we divide the a term until we have x squared. So we'd have to actually divide this by 2. Now, you can't just randomly divide part of it. You've got to divide the whole thing. So I'm going to divide each one by 2, and I end up with y over 2 is equal to x squared plus 3x plus a half. All right, once you get it to this form, it's just regular completing the square until we get down to the very last step. So we minus the half on both sides. So that's y over 2 minus a half equals x squared plus 3x. Okay, so I just move the half over. Take half of the b term and square it. So 3 divided by 2 is 3 over 2 squared. So it's 3 over 2, and then squared is going to be 9 over 4. Or 2.25 if you really have to. So y over 2, I forgot to add it over here, plus 9 over 4. So y over 2, negative 1/2 plus 9 over 4 is 7 over 4. X squared plus 3x plus 9/4 we know is going to factor as x plus 3 over 2 times x plus 3 over 2, which is x plus 3 over 2 quantity squared. So y over 2 plus 7/4 is equal to x plus 3 over 2 squared. Move the 7 over 4 back. X plus 3 over 2 squared minus 7 over 4. Okay, now this is where it differs. We don't want this to be y over 2, we want it to be y. So what we want to do is multiply both sides of the equation by what you originally divided by. So since we divided by 2 back here, we've got to re-multiply this by 2 here and here. So we have to do the entire thing. Now be careful. When you multiply 2 by 2 here, the 2's are going to cancel, leaving y, and that's what we wanted. Now, remember, this 2 multiplies both of these terms, but can I actually distribute the 2 through here? No, because this is in parentheses of the squared, I actually just have to put it out front. So it's x plus 3 over 2, quantity squared, and then here, set negative 7/4 over 2, when I divide this into here, it becomes minus 7 over 2. So, what's my vertex? Remember that the a value does not affect the vertex. The vertex comes from here and here. So your vertex is actually going to be negative 3 over 2, because it's the opposite sign here and the same sign here, negative 7 over 2. Or if you really want to do it in decimals, negative 1.5, negative 3.5. So you can do either one. All right, so basically all you have to do is divide it out first and then remultiply when you're done. All right, let's try a couple more. I'm going to divide everything here by 5 because I want this to be x squared. I get y over 5 equals x squared plus 4x plus 23 over 5. Don't worry about the 5, we'll deal with it later. All right, move the 23 over 5 over here. Equals x squared plus 4x. All right, we want to take half of the b term and square it. So half of the b term would be 2, and 2 squared is 4. So this is going to be x squared plus 4x plus 4 equals y over 5 minus 23 over 5 plus 4. All right, combine your terms here. This is going to be y over 5. Negative 23 over 5 plus 4 is negative 3/5. And this is going to factor as x plus 2, because that's what the middle term was for that. So this is x plus 2 quantity squared is equal to y over 5 minus 3/5. Move the 3/5 back over. This is going to be plus 3/5. And now we have to get rid of this 5, so we have to multiply this by 5 and this entire thing by 5. So that gives me y equals 5 times x plus 2 quantity squared, and then these 5's are going to cancel, plus 3. So your vertex for this one is going to be at negative 2, 3. All right, let's do one more. What do we have to divide this one by? We actually divide it by negative 2. Divide everything by negative 2. So that gives me y over negative 2 equals x squared minus 2x minus 7 over 2. All right, move the 7 over 2 over here. So this is going to add 7 over 2 equals x squared minus 2x. Take half of the b term and square it. Half of the b term, negative 2 is negative 1 squared is 1. So we want to add 1 to both sides. Is equal to x squared minus 2x plus 1. We know this is going to factor as x minus 1, because remember half is the negative. And then 7 halves plus 1 is 9 halves. And then x minus 1 is x minus 1 squared. Move the 9 over 2 back to the other side. And then multiply both sides by negative 2. Don't forget your sign. All right, when you multiply this, you end up with y equals negative 2 times x minus 1 quantity squared. But when this is negative 2, watch your sign here. Negative times a negative is actually going to be a positive 9. So your vertex for this is actually at, I'll put it up here, your vertex is actually going to be at 1, 9. That's your vertex. Now, actually, the completing the square formula gives, on the quadratic equation formula, will take this and actually turn it into this, if we're actually not going to do that, but it will. All right, so if this is equivalent to this, using completing the square, what would be the x-coordinate of the turning point of any parabola? Well, it would be this value right here. So x is equal to, remember it's the opposite sign, negative b over 2a. So this is actually what's called the equation of the axis of symmetry of the parabola. It goes exactly through the center of the parabola, the vertex, and it'll give you the x-coordinate. So we're going to use that equation to find the vertex. We'll finish these notes in class the next day.